Wait. That is my rocket relay. I made it a couple weeks ago out of a 3D printer and some glue I had, also duct tape. In this video I'll be showing you how I made the CAD model for my rocket. Alright, so this is my basic model of the rocket that I have in Tinkercad. I am not very experienced in Onshape, so I use Tinkercad instead. So I modeled the rocket after what's it called? It's the High Flyer by Estes, and also used the Tinkercad base rocket to help sculpt kind of like it. So if we ungroup this, and I will take away the rest of the fins, we are left with main body tube. These are the fairings, and a wing, or a fin, so the fairings are meant to go together and go inside. If you can see, there's a little overhang right here. So on the underside of the fairings, there's a little clip that you can see right here. That will clip on underneath of the little overhang and keep the fairing in place. So that's what you see flying off in the launch video. So I originally designed it to just be able to hold a small little like Lego piece or something, but I eventually realized, hey, using a clamshell fairing would be really cool. I've seen that in a bunch of real rockets. So I decided to model it after that. So I started everything with a bunch of tubes and anything that I could really think of using for the rocket. So as you can see, I have a bunch of revolve things, and if you don't know what that means, if you go over here, there's a revolve tool. So you take it, it shows you this view. So then you make any shape you want, like that. It could be anything. And then you can look here, and it'll make that shape into a 360 pattern. So that is really helpful for making rockets and stuff, because it takes your shape and puts it into a perfect circle, basically. So if we take those out, this is the completely unfolded rocket base. So everything here together, and if you group it in a specific way, it will make the rocket body. Yeah, there's also that piece. And those. This right here, that's what's supposed to keep the engine in place. And everything else is for it to work with the fairings and not burn and melt the inside. Kind of during that process, I made the wing, or fin, whatever you want to call it. It is made out of some pretty simple parts. So basically what I did was I took a very long roof. So if you were to take a roof piece and turn it 90 degrees, then turn it 90 degrees on its side, you can get it to be long, thin, and tall. So what I did with that is I turned it on its side and duplicated Arduino. Oh wait, yeah, so I took the roof piece, I turned it on its side like this, and then if you make it short and you raise it up a bit. How did I make that? Well, you can kind of see the basic shape of the wing. So then I use this really long cutout thing to make the roof cut in half. So I took these, highlighted them, and grouped them. Then what I did is took these, put them close to each other, then took these and centered them with the align tool. Then you can make them close and highlight the smaller roof and the larger roof to make the bottom part, and that's what allows you to have the cool underside of the fin. So highlight those and group them. So now you can see that shape that I have right here with the underside. So I did that, and I just made a little roof, made it really skinny, and aligned them here. I also grouped these so that doesn't happen. And yeah, so now you have these, and you group them. So that's one fin. You just, the way I do it is I take the size of the center body, I take one fin, duplicate it, move it over to the other side. So imagine this piece is the center body. Move this over until it reaches out. Flip it 90 degrees, 180 actually, and make sure it make sure both of these fins are inside the body, but not too much inside, because you don't want to lose too much of your fin. So I would say like that. Then what I do is I take 1 and 2, and I duplicate that and turn it 90 degrees. So now you have 4 symmetrical fins. Then once you group the rest of the body, you can do that, and you get the main body and fins of the rocket. Alright, now I am going to show you how I made the fairing. So if we ungroup the fairing, we have 113 shapes. How did I end up with that? Nobody knows. Oh, I get what it is. So, for the cone, this part, I used a cone shape. So if you go here, you type in, you can get this, or what I like to use instead, let's see if I can find it, yes, is paraboloid. So I took this, I duplicated it, and made one that is slightly bigger. I made this one disappear, put on, so this is now a hole, so when I group them, make that reappear. So now when I group them, there is now a hole on the inside, so that's where the payload would go. Then I split it in half, and so you have this part right here, that is done. This part was a little bit more complicated. So this is the basic shape. Again, I used the revolve tool. So if you ungroup it, you get a bunch of these crazy shapes that somehow, when you put it together, form, oh gosh, it's an empty shape. That's cool. I don't know how that happened. So, oh, I know what it is actually. So each of these is a individual shape. So I use the revolve tool for it. So if you ungroup this, you get this shape, which is, you can see there's the initial revolve in the middle, and then I just used the hole tool to block out everything except this one little tiny piece, and then I just duplicated that a bunch of times at the angle I wanted. So oh, I also used a good way to help for me make a perfect circle with them is to take these two, then I highlight this other one, then I duplicate it and move it 22, actually at 45-degree angle. I just duplicate that a bunch of times until I end up in my initial spot. Then you just go and delete the inside ones, and now you have a perfect circle of these. Then you remove half of them, or you can cut these straight down the middle like I did, and connect it with the cone. you also need to make the bottom part a little bit. You need to have a little bit of a hole. I did this one about 1 millimeter high, just because if it's exact fitting, I had this problem. If it's exact fitting, it will not close, and therefore it will not work. So that's how I made that part. So then, if I come over here, get these, that is the completed rocket. This little thing right here, this is a Estes B size motor. I know it says A, B, C, but it's a B size motor, or rocket motor. So you can use that for fitting, and it works really well. You can see the video of the rocket, and yeah, it works surprisingly well. Thank you for watching,